All right, so this is our very last one. We're going to do Pemdas, order of operation. So this is the order that you do math in. Whenever you see a big, long problem, and this goes for all math, right? Whether it's algebra, trigonometry, calculus, whatever, there's the order of operations. You always follow it. It's so that things are consistent and everyone follows these rules, because if you don't, then you can have the same problem and people are going to get different answers out of it, right? So we use this rule to make sure all of our math problems are done correctly, right? And so the PEMDAS just stands for parentheses, exponents, multiplication and division. Those are together. Okay, multiplication and division, and addition and subtraction also together. So you consider them equal. Again, and remember I talked about before how you can change addition to subtraction, you can change division to multiplication, which we'll go over in a few weeks, because they're technically, they're so related, they're actually technically the same thing. We saw that with addition and subtraction, right? You can rewrite it. Right? So it's not like you don't do multiplication first then division. You just do them in order that you see them. You do your parentheses first. Anything in parentheses, whatever's inside, you do it. So if it's multiplication, if it's division, if it's addition, subtraction, you do what's in the parentheses first. Then you do exponents. I'm not going to go over doing any exponents yet, mainly because we're going to get more into that next week. Then you do any multiplication and division from left to right. And again, you don't pick one over the other to do. You always just go whatever you see. If it's multiplication or division from left to right, you just do it. Okay? And then you do addition and subtraction from left to right. That's your last step. Oops. Okay, so I've got this problem. 4 times, remember, if a number is next to parentheses, that means you're multiplying it. 4 times in parentheses 5 plus 2 plus 3. So I do my parentheses first, right? So I do 5 plus 2. That gives me 7. And I always just like to rewrite my problem and do each step. Ooh, I'm really sorry. That was my laundry. Then I do exponents, but again, we're not going to do exponents yet. So if there was, you would do the exponents. Then you would do multiplication and division from left to right. So we have 1 multiplication right here. 4 times 7, we get 28. Then we do the addition and subtraction. So plus 3, and we get 31. Okay, this one, sorry if that's not clear, that's a subtraction sign. So 2 times 4 plus 1 minus 6 divided by 3. Okay, so this is a unit, it's a division unit, but it's written as a fraction. Right, because we read it as fractions now. Okay, so I'm going to do my parentheses first. I get 5. Then I'm going to do multiplication and division from left to right. So I don't do like division first, multiplication first, or anything. I just go like I'm reading. So I'm going to do this one first. 2 times 5 gives me 10. 6 divided by 3 gives me 2. And now I can do addition and subtraction. So in this case, it's just 1 subtraction, and I get 8. Yeah. Okay, here's another one. Um, 2 times 1 plus 3 plus 3 times 4 minus 2. So I'm going to do my parentheses first. I got 4. I got 2 in the parentheses. Then I'm going to multiply in order from left to right. I get 8 and 6. And then I add them, and I get 14. Alright, I think I'm going to do this last one. I was contemplating doing it, and now that I'm here and the videos are shorter, I will do it. This is called the distributive property. Because doing it now when it's simple will actually be helpful than if I introduce it with variables. So, and this kind of relates to like here, right? So let's do that one. So this is going to look like really ridiculous again, doing it like this, when we could easily do it the way we just did it up here. But we're going to do, so if you remember, this is multiplying, right? So whenever you're multiplying a number to something in parentheses, but you have like multiple numbers in there, whether it's addition or subtraction, you can actually, it's called distribution because you're going to distribute the 2. You're going to, like, everyone that's in the parentheses is going to get that 2 to multiply. Okay. So we say 2 times 1 plus 2 times 3. So if you see, I distributed it to 1, so I'm multiplying these 2 together. I distribute it to 3. That's where I got this, 2 times 3. And I carry down my sign. Okay, so 2 times 1 is 2. 2 times 3 is 6. That gives me 8. So if we look up here, if we do it the other way, the Pemdas way, right, it checks out. We get 8 either way. So you can see that doing it either this way, this is the distributive way, or this way, we're going to get the same answer either way. Okay, so again, this looks really pointless when we're using real numbers. When we start having variables, though, you're going to be using the distributive property a lot, because you'll get things like this, and it'll be like, well, I can't add x and 5 together because I don't know what x is, right? That's the whole point. We're trying to figure out what x is. So this would be one of those cases where you distribute. But I don't want you to think too hard about it. Just kind of like showing you what's coming. But don't worry about that right now. Just worry about how to distribute with numbers. Right? And same thing if you have like subtraction. Okay, so if we do it like the Pemdas way, so we get 5 times 8 minus 3 is 5. 5 times 5 is 25. If we do it the distribution way, 5, so we get 5 times 8, right? I'm going to carry down my sign. This time my sign is subtraction, so make sure you pay attention to that. Then you get 5 times 3, right? I distribute it to each. Everyone gets a 5 inside. 40, 15, and I end up with 25, right? So it checks out. Doing it either way, we get the same thing. They equal each other. Right, so this is just to prove to you that this works. This distribution property is a real math property, and it is valid. And because it comes in handy later in algebra when you don't know all the numbers on the inside. Okay? And you can also do it with like multiple numbers, so like that. So I can distribute to all. So it would be 2 times 1. I carry down my sign, the plus. 2 times 2. This time, right, I'm carrying down a minus. Okay. 6, 0. Right, and if you want to check it, 1 plus 2, just to show you that it works either way. You have to do the order of operations within your parentheses. And remember, zero product rule, anything times 0 equals 0. So it checks out. We get the same thing no matter which way I decide to do it. So I just wanted to go over the distributive property with simple numbers, just to show you that this works, this is valid. So when you get to variables, hopefully it will make more sense. All right, so that's everything for the review for this week. And after watching all of these, if there was a topic that you have more questions on, that you need more examples on, that I went too fast on, please bring it to our Zoom sessions. I will gladly answer any questions that you might have on them. I'll do more problem sets, whatever, I can do tons of examples. So that's what those like live Zooms are going to be for. But yeah, so hopefully this is useful, and I will see you later.